Greetings, everyone. In this video, we will show you the main features of Hillstone Network's CWPP solution, CloudArmour, and illustrate how CWPP can safeguard our workloads with a practical case. The dashboard is the first thing that greets you when you log into CloudArmour. It shows the status and performance of your workloads across different cloud platforms, including the situation of viruses, compliance, vulnerabilities, intrusion events, logs, and some ranks. Next, Insight. It enables you to visualize the internal communication between services and applications within your cluster in the cloud environment. It shows you a clear picture of how they interact with each other using icons and arrows. On the Insight page, you can view the default global view, or create a new view to focus on the specific namespace, application, service, or host group that you are interested in. Let's look at the global view as an example. It gives you multiple angles to see your security status, such as vulnerabilities, compliance, behavior, intrusion, traffic, virus, etc. Then let's explore CloudArmour's asset management. In the data center, you can see all your clusters as well as the hosts and containers inside them. You can define new clusters here. You can also click on them to see more details, such as what services they are running and what packages they have installed. In the Discovery section, you can see how your assets are categorized by type, such as web assets, database assets, processes, services, and so on. In Workloads, you can see your assets from 4 different angles: hosts, containers on hosts, Kubernetes applications, and labels. On the Image page, you can see the information on your image repositories and local images. You can also create new image repositories and scan them and your local images for compliance, vulnerabilities, and viruses. Following that, let's look at the 4 core features of CloudArmour's security protection: risk management, compliance management, threat prevention, and policy. Firstly, risk management covers vulnerabilities and weak passwords. On the vulnerability trend page, we can see the vulnerability status of hosts and images in the past 30 days, as well as a list of existing vulnerabilities. On the host vulnerability page, we can launch a host vulnerability scan task by clicking Scan Now and setting a scope for the scan. Once it starts running, we can view the details of the vulnerabilities after it finishes. We can also edit or rerun this task on the host scan page. The same applies to image vulnerability scanning. As for weak passwords, they are easier and faster to check since they are separated. The weak password content can be viewed by admins and it helps find and fix the weak password issue quickly. We provide a default dictionary for weak passwords, but you can also add your own entries as needed. Secondly, compliance management. We offer predefined compliance assessment templates for hosts, containers, and images, and also allow custom compliance check template. You can choose a specific asset type and decide what to do with the compliance standards, alarm or ignore. Click Check Now to start a compliance check task. You can see the analysis of the check results on the trend page or view the detailed check results on the subpage. Thirdly, threat prevention, which includes intrusion prevention and antivirus. For intrusion prevention, we make additional efforts to protect against the most critical and frequent abnormal logins, reverse shells, and privilege escalation. For example, for abnormal login, we can use a predefined template to set up policies quickly. We just need to specify the defense scope, the trigger condition, and the action. The detected events are shown here and we can also block IPs or configure the allow list manually. Moreover, for other kinds of intrusions, we offer a rich signature database to help users create their own policies. For antivirus, there is also a trend page to see the overall status. We can assign tasks and send them to hosts and images. We can handle virus files directly in the tasks where they are found. In the subtab, we can see the quarantine zone, trusted files, and logs. Fourthly, the policy includes microsegmentation, runtime, and admission control policies. Microsegmentation controls the traffic forwarding between different assets or address segments by configuring policies. We can configure different policy groups and then configure policies within them. To assist administrators in configuring security policies more quickly, accurately, and comprehensively, CloudArmour provides a policy helper. It retrieves traffic logs that hit the specified policy setting within a designated time period, aggregates the source and destination addresses, generates the optimal traffic model, and automatically generates the corresponding policy based on the traffic model calculation results. Additionally, to facilitate IP address referencing and flexible configuration, CloudArmour supports the address book function. Users can assign a name to an IP address range, and when configuring, they only need to reference that name. Runtime supports real-time monitoring of dynamic data for cloud workload assets during their operation. It can monitor, analyze, and control the behavior of processes, network services, file system access, and system calls. Learning about the behavior of an asset's processes, network services, and file system access, it establishes a security behavior baseline for images, containers, or host assets. When behavior is detected that exceeds the security behavior baseline, an alarm and control will be triggered. Users can configure the learning time for the behavior model on the behavior model page and view the model details. Users can also configure custom operational security rules on the behavior rules page or convert the learning model into rules. Admission control policies validate pods that are about to be created or updated in the Kubernetes cluster. If there are compliance, vulnerability, or virus risks for the pod that is about to be created or updated, specific conditions can be configured here. CloudArmour can then issue an alarm or block the creation or update of that pod. In addition to security protection, CloudArmour also provides detailed logs to help administrators better maintain the workload environment. These logs include security event logs and maintenance logs, and CloudArmour supports forwarding the generated log information to a log server. After understanding the main features of CloudArmour, we will attempt to use one host within the cluster to invade another host and implant a virus into it. During this process, we will observe how CloudArmour protects the target host. To start with, we need to make 4 preparations beforehand. The initial step is to enable the microsegmentation and intrusion prevention functions on the target host. The second step is to include the cluster, where these 2 hosts are located, in the microsegmentation scope. The third one is to configure an intrusion prevention policy, where we will only set an alarm at the beginning so that we can see the situation without CloudArmour's protection. Lastly, we will set up a virus scanning task for the target host in advance. To begin this case, the first step is for host A to perform a brute force attack on the account password of host B. Success, we have obtained the account password for host B. Meanwhile, we can also see that CloudArmour has alarmed us to this brute force attack event. Step 2. Host A makes an SSH connection to host B using the password we obtained in the previous step. And we can see that we have successfully entered host B. Step 3. Implant virus on host B. Navigate to the /user/bin directory and check if the nop_10.zip virus file is present. Step 4. Execute the virus scanning task that we previously configured. Since the configured action is to delete virus files, after the task is completed, we can see in the task details that the scanned virus file has been deleted. Let's go back to host B's interface to confirm that the virus file in the /user/bin directory is indeed no longer there. Finally, let's see how CloudArmour defends against brute force attacks. In the brute force attack event that was detected earlier, we can choose to block the IP address involved in the event. After doing so, we can see in the blocked IP section that access from host A to host B has been blocked. Then we can go back to host A and try to execute the same brute force attack command again, but this time we can see that the attack has failed. Thank you for watching this video. We hope it has helped you better understand Hillstone Network's CloudArmour CWPP solution.